Okay, welcome to the first of a set of tutorials for GCSE chemistry. We're going to look at one of the trickiest topics that people find difficult in GCSE, and this topic can be represented by this little chap here. So the title of the topic is going to be moles, and obviously where we start is we start with an introduction. Okay, it's one of the most difficult topics people find because it's quite abstract. It's to do with very, very small particles, and it's nothing to do with this little chap here. Right, so what is it all about? Well, essentially a mole is simply a number. So a mole is a number, and it's a number in the same way that a dozen is 12. And a century, when someone reaches a century in cricket, a century is 100. Now the problem is with a mole is a quite difficult number. So a mole, rather than being a dozen or 100, a mole is 602 Now that's what a mole is. It's 602,000, 1,000, 1,000, 1,000, 1,000, 1,000, 1,000. It's an exceptionally large number. It doesn't really matter what that number is, but that's what a mole actually is. It's just a very large number. And the reason it's a very large number is because it counts very, very small things. Very, very small things in this case is atoms. So that's what a mole actually is, but in fact you can do calculations with this without even knowing that. Let's have a look at what I mean. If we take, excuse my drawing here, if we take a bar of iron, the question is this, is what is it actually made out of? Well, it's actually made out of lots and lots of tiny particles here, and these tiny particles are called iron atoms. They are far smaller than I'm drawing them here, and they are far too small to measure. So whereas we can understand that this is made of iron atoms, we can't actually count them. But that's actually what the substance is made of. So what we need to do is we need to find a way of working out the actual number of iron atoms from this bar of iron. But of course we can't do that by measurement. So what we have a look at is we have a look at an equation. Now this equation is going to relate something that we can measure, and that's mass. We can measure the mass of this iron bar easily just by weighing it, and it's going to relate something that we can't measure, and that is moles. And remember, a mole is just a number, and in this case moles refers to the number of atoms. Now clearly number of moles does not equal mass. The mass of an iron bar would have no particular relevance to the number of moles, so this equation clearly isn't complete. This equation is complete, however, if we place mass divided by something called AR. And AR down here stands for relative atomic mass. Every single substance has a relative atomic mass, and it can be found out from the periodic table. So for example, if you take the element sodium in the periodic table, the element sodium has got the, actually I'm not going to use that, the element sodium has got the symbol Na, and you'll find it in the periodic table. It looks like this, and it's got two numbers next to it. The numbers in sodium will be 11 down here and 23 up here, and you'll find that that number is the AR of sodium. It's always the bigger of the two numbers. Okay, so to recap, what we've got here is we've got an iron bar. It's made of atoms, and we know that. We want to work out how many atoms on the left-hand side of the equation, and to do that we take the mass of iron, which we can work out, and we divide it by its AR. Now if you look at iron in the periodic table, you'll find iron has the symbol Fe. It has a smaller number, which is 26. It has a larger number, which is 56, and therefore the AR of iron is 56. Always the larger number, and you can always get it from the periodic table. Okay, let's skip on past sodium again, and let's see how we can work out our iron bar. So see if we can do this a little bit better this time. Here's my bar of iron, and let's suggest that we put it on a balance, and we work out that the iron, coincidentally, weighs 112 grams. We put it on a balance and it weighs 112 grams. What we can now do is we can use our equation. Moles is equal to mass divided by AR. Remember that now. Skip back to iron. Remember the AR is 56. Skip forward. And therefore the calculation here becomes moles equals mass, which is 112, divided by AR, which as we know is 56. Find it out from the periodic table. And hopefully you can do that in your head. But if you can't, 112 divided by 56 is equal to 2. Now remember, that is 2 moles. What does a mole mean? Let's skip forward again. A mole is that number. And if we've got 2 of them, that means that we have the number of atoms is 2 of that lot. Because this is a complicated number, a large number, we don't deal with actual numbers. We deal with pretty simple numbers, such as number of moles. Okay, we'll do one last one. Let's have a look at a substance called sulfur. Sulfur here, we look at it in the periodic table. Sulfur has 2 numbers. It's got 32 up here, it's got 16 up here. The AR is always the larger one. That's that one there. And if we want to weigh, if we have a large, nice kind of block of sulfur here, it's useful I've got the yellow pen, and we say that our sulfur block, this one here, has a mass of 8 grams, we now know that the number of moles of sulfur from our formula, moles equals mass divided by AR, which is equal to 8 divided by 32, which is equal to 0.25. 0.25 moles, if we remember that 1 mole is that really large number, means 1/4 of that really large number. And that's the basis of working out moles when you're dealing with mass.